Hello, we are going to look at trends in reactivity in the periodic table, and this is for the higher tier and required for the higher tier only. So let's start off straight away. We're going to look at elements of the periodic table. Here is a tiny periodic table. Don't worry if you can't zoom in and see that, because what we're going to focus on is group 1 and group 7, which we've looked at before. And the key thing to remember about group 1 and group 7 is that when you go down group 1, the elements become more reactive, and when you go down group 7, the elements become less reactive, and therefore the more reactive elements are at the top for group 7. This is group 7, this is group 1. Almost look the same. Group 1. Okay, now the key thing that you need to remember is that, well, you have to be able to explain this, and the key thing you should remember is that the higher energy level of the outer electrons of the atoms, the more easily the electrons are lost and the less easily the electrons are gained. And you should be able to use this to explain why fluorine is less reactive than iodine, and also the same idea in this little paragraph or couple of sentences to explain why cesium is much more reactive than sodium. So let's have a closer look at the atoms. Here are two atoms from group 1, and as we said, the further down you go, the more reactive the elements. Remember, this is group 1, and the way we think about this is we look at the outer shell electron. Remember, there is only one electron in the outer shell of the group 1 elements, and it's the same for all group 1 elements, one electron in the outer shell. I haven't drawn all of the electrons in just for the sake of avoiding confusion, but we've got our one electron there, and if you look at the distance between the electron and the nucleus, it's quite short for the higher up element there, and it's a bit longer for this element that's further down. The distance is actually longer, and if we look here, it says the higher the energy level of the outer electrons, remember these shells are also called energy levels, the more easily the electrons are lost. And this helps us to explain why this atom here, or this element here, is much more reactive than this one further up. And the best way to explain it is as follows. We've got the outer electron is closer to the nucleus for this atom here. There's a stronger attraction to the nucleus, or the attraction to the nucleus is strongest. There is less screening by inner electrons. So what actually happens is the electrons that are in these inner shells, they actually carry out something called screening, which helps to reduce the force of attraction between the electron and the nucleus. We call it screening, sometimes we can call it shielding. So there is less screening or shielding by inner electrons, and that means electrons are lost less easily, or electrons are not easily lost. That means this is going to be less reactive than this atom here. Remember, group 1 elements rely on losing these electrons in order to be able to react with other elements. Okay, so that's how you'd explain why this element here is much less reactive. How would you explain why this one is more reactive? Well, similar idea. I've used the very same framework, but just changed the words around a bit. So we've got the outer electron, which is further from the nucleus. As you can see, this red distance is further. That means we've got a weaker attraction to the nucleus, or the weakest attraction in comparison to other electrons in other shells. We've got less screening or less shielding by, no, that's wrong. Sorry about that. We've got more screening by inner electrons, or more shielding, which means the force of attraction to the nucleus is weakened, and that means the electron is lost more easily, which means that this is going to be a much more reactive element. And this is how we would explain the reactivity in the group 1 elements as you go down the group. Remember, we are explaining, so this is how we explain it here. Now, if we were to focus in on the group 7 elements, remember, as you go down, they become less reactive. That means the elements for group 7 the higher elements are less reactive than the lower elements, and we have to use this idea that the higher the energy level of the outer electrons, the less easily the electrons are gained. For group 7 elements to react, they have to gain an electron, and that's when a reaction would happen. And if electrons are easily gained, we have a reaction. For elements that are further down, you can see the distance again is further. The distance of the electron from the nucleus is further, so that means it's going to be less easy to gain that electron. That means it's going to be less likely to react. It's going to be more difficult for it to react. You might want to have a go at explaining why this element nearer the top is more reactive for group 7 than the elements that are lower down, and it's to do with this idea here. We use this as a framework for our answer, and you can give that a go now if you want, and check your answer against mine. If not, just keep watching and we'll go through the answer now. So we have the outer electron is closer to the nucleus for this element that's higher up. That means there's a stronger attraction to the nucleus. Again, it's very similar to what we did. The first 3 lines are very similar to what we did before. So there's less screening by electrons. Electrons are gained more easily. That means because the electrons are gained more easily, that means it's going to be more reactive. And by now I think you're getting the picture. I bet you can do this one very simply. Outer electrons are further from the nucleus. There's a weaker attraction to the nucleus. There's more screening or shielding by the inner electrons in the inner shells. Therefore electrons are gained less easily. It's harder for an electron to actually join onto that energy level. Look, it's having a really hard time. It's not actually, that force of attraction is not enough to hold it there very easily. So this is a much less reactive element from our group 7. Okay, so I hope that made sense. Remember, you must be able to explain why these things are more reactive, and this is how you do it. So that's me done for now. Thank you for watching, and I'll see you again soon.